Welcome, everyone. I'm Erik Brynjolfsson, and this is the Stanford Digital Economy Lunch Seminar. We're going to be having a presentation today. We're very fortunate to have Rob Seamans, who got his PhD at Berkeley, who's a professor at NYU Stern School of Business, presenting his work on robots at work in China with Nanjia and Qiren Lui. Rob Seamans is the director of the Center for Future of Management at NYU. His research focuses on how firms use technology and their strategic interactions with each other, and also focuses on the economic consequences of AI, robotics, and other advanced technologies. His research has been in a number of leading academic journals and widely cited. Back in 2015, he was appointed the senior economist for technology and innovation on President Obama's Council of Economic Advisors. Rob's going to present for about 45 minutes, and during that time, you can put questions in the Q&A function here at Zoom, and we'll pick out some of those questions to ask Rob. And then for the last 15 minutes, after about 45 minutes, we're going to have a more general discussion with Rob, diving into these issues more broadly. So please use the Q&A function for any questions you may have, and Rob and I will pick them out and answer them along the way. Rob, welcome here, and please tell us about robots at work in China.
Will do. Erik, thank you so much for inviting me, and thank you to everybody who has joined us today. I'm really excited to present It's joint work with Qiren Liu from Guangzhou University in China and Nanjia from the University of Southern California's Marshall School of Business. And again, I'm Rob Seamans. I'm a professor at New York University. So the title of the talk is Robots at Work in China. To motivate this a little bit, let me remind you of some of the ways in which robots and AI have been in the news lately, right? So there are lots of articles out there in the popular press mostly around robots and AI and how these technologies are, perhaps can be great for the economy, but maybe from a society point of view, might not be so great in the sense that they might take a lot of jobs. So I've been really interested in this topic, and I've got research papers, popular press articles, and sort of research in progress that sort of focuses on AI, robots, and the effect that these technologies are going to have on the economy. One area that I've been particularly fascinated by is robots and the different ways in which robots get used. This sort of background picture, if you can see it, it's a little, I sort of intentionally sort of faded it into the background. It's a picture of robots in a production line, an automotive production line in China. So part of the reason I like studying robots is that they're relatively easy to count, right? They're relatively easy to measure. And so in terms of trying to estimate what the impact of these technologies are on firms, workers, the economy, it's relatively easy to do relative to something like, say, AI. So for the rest of the talk, I'm going to focus, even though just a moment ago I had AI up there. For the rest of the talk, I'm going to be focused on robots, but perhaps towards the end, and maybe during that, especially that 15-minute Q&A at the end, maybe we can think about how some of the things I'm going to be talking about today might also apply to AI. But for now, we're just going to be focused on robots. So a couple of things to note about robots. The first is that worldwide, there's been sort of a dramatic increase in the shipments of robots. So if you look at the figure on the left, this is showing up through 2016. I probably need to update that. Through about 2010 or so, there were roughly 100,000 units of robots shipped every year. This data comes from the International Federation for Robotics, IFR. I'll talk more about IFR a little bit later in the talk. Starting roughly in 2010, there was then a dramatic increase, and now we have, again, I need to update it a little bit, but now we have about 400,000 units that are shipped worldwide. Now, a lot of where these robots end up, I mean, they end up in all the large economies, as you can imagine, including in the US, but China is really one of the places where there have been lots and lots of robots shipped. China now has a growing, if you sort of focus at the chart on the right, China has been growing its own domestic supply of robots, but up until 2013, they didn't have any domestic supply of robots. And that's going to be useful for us because part of the way that we're going to be able to measure the extent to which firms are adopting and using robots is by using data that comes from imports. And we're going to use that to identify the firms that have imported and are using robots. So that's part of the reason why I'm going to be focused on China. Actually, let me just pause for 1 sec. So, Erik, if there are any, I'm not going to be monitoring the questions, but if there's anything that's really pressing, please just let me know.
Yeah, absolutely. I'm monitoring the Q&A function, not the chat, but the Q&A function, and I will periodically ask you to address some questions.
Great, thanks, Erik. One of the other things about China, and part of the reason why we're doing this paper, is that more recently the Chinese government has really had a focus on the country developing its own internal capabilities around new technologies. And part of the way that the country will be doing this is by really relying heavily on state-owned enterprises. And so they're going to be playing a big role. So I'm highlighting that now because as we sort of start to get into the paper, start to get into the presentation, you'll see that that I have a very heavy focus on the role that state-owned enterprises are playing when it comes to robots. Okay, so we'll come back to that. First, let me just sort of step back a little bit and situate this academic paper in the literature. This is not an exhaustive list of the literature, but I just want to highlight a few papers that I think are relevant. So the way that I think about the literature, the economic literature around the role of robots, is you can sort of put it into sort of two buckets. There's one bucket that uses this IFR data that I highlighted earlier. And there's some interesting findings that have come out of that. More recently, this is sort of the second set of papers that I'm highlighting. There are a number of papers that have gotten firm level data on robots, and they're using this firm level data to estimate the impact of robots on jobs and productivity and things like that. One paper in particular I want to highlight, because our paper borrows methodologically from that paper, is this paper by Dixon, Hong, and Wu. And so what those authors do is work with Canadian import data to identify the firms that are importing and using robots. And we're going to do something very similar there. So there's the papers that have this firm level data on robots have a common finding. Okay, and the finding is that the firms that, or sort of three common findings. One is that it tends to be large firms that are adopting these robots, large, and they tend to be the more productive firms. Second is that firms that are adopting robots see an increase in employment, more of an increase than they otherwise would have. And third, that there's an increase in productivity, so if you will, performance in the firms that are adopting robots. Okay. This interest in robots and the effect that robots have on firms and on the economy is part of a much longer suite of papers of literature that looks at the effect of automation in general, or new technologies in general, on economic outcomes, right? And so people have been interested in steam engines and electrification, early IT, and so interest in robots and AI is sort of part of this, right? Trying to understand how these new technologies are affecting firms. Now, one of the interesting findings, and Erik has done some work in this area as well. One of the interesting findings is that when firms adopt these new technologies, it can take a while before they see productivity growth. And the reason for that is that the firms need to make additional investments, right? So you can't just purchase AI, right? Or you can't just purchase robots or just purchase electricity and then see productivity growth. You have to actually make these other complementary investments. And again, this is something that Erik has written a number of academic papers on. And so while we think methodologically, I'm just going to go back a slide, we're sort of following this Dixon, Hong, and Wu paper from a, if you will, from a theoretical point of view. Really what we think that we're doing is, following some of what Erik has been doing when he's looking at AI and predictive analytics and the role of complementary investments. So what I'm going to do next is I'm going to try to put a little bit more meat on the bones of this idea of complementary investments by sharing with you some of what I've seen when I've gone to factories here in the US, in the Midwest, that have been putting in place robots. So it's not China, right? I have not yet traveled to China because of COVID, but at some point I hope to see how they've been putting in place robots. But I'm going to show you some pictures from what I've seen in plants in the Midwest. Okay, so the first one, this is Sandwich, which is outside of Cleveland, Ohio. So Sandwich is part of the automotive supply chain. They're upstream from the automakers. What these guys do is they stamp metal, right? They make metal parts. Could be as big as a door, or it could be some small little metal piece that gets used somewhere in the body of the car. Okay, and so I'm going to use my cursor to sort of highlight a few things. So this is their production line, and you can see that there are a couple of robots here, right? So this firm invested in robots, but it's not enough to just make the investment in robots and then get the productivity boost. They also needed to make other complementary investments. So what are those complementary investments? They had to invest in this. They had to actually create from more or less from scratch this appendage at the end of the robot that is holding the piece of metal. So this is a little piece of metal that is getting presented to, this is a stamper. This is a relatively small metal stamper, right? And so this robotic arm has to hold that piece of metal, and then it gets presented to the stamper, okay? Notice that there's these blue lights here. We're going to come over to this picture here that's on the right. You can see some more of these blue lights. So these are sensors that they had to invest in to help make sure that the robot is lining up properly with the stamper. You can also see the camera that's back there that's capturing a video feed. You see the wires that are taking that video feed, and where are they taking it? They're taking it to this computer that's set up. It's actually several computer screens set up over here on the other side of the cage, and there's this gentleman who is monitoring what's going on. So they've had to invest in not just the robotic arm, but also additional physical assets, additional digital assets, if you will, as well as additional human capital. Okay, all of that just in order to take advantage of this new piece of equipment that they have here. Okay, so the way that I like to think of this is that these new technologies are not quote unquote plug and play, right? You have to also make these complementary investments. This would be another example from Jabil Systems. They're an electronics manufacturer. Again, you see they've purchased this robot. You can tell it's from Epson, but they've also had to make a whole bunch of other investments. And here, this is sort of a stock photo actually from McKinsey, but it highlights, I guess in this case, sort of the role of the human capital that also needs to be invested in. Okay, so what are we doing in this paper? We're interested in trying to understand how the firm level adoption of robots affects firms in China, okay? We're gonna be looking at things like productivity, employment. We think it's an interesting and important question given the large role that China plays in the world economy. What do we find? We find that on average, at the firm level, robots lead to higher productivity and employment. Okay, so that's on average. Now, it turns out that there's actually some interesting heterogeneity. Chinese state-owned enterprises, right? We also observe some of them adopting these robots. However, we don't see them getting this same productivity and employment boost as the private-owned firms, okay? That's sort of the second thing that we're doing. Then the third thing that we're going to do is we're going to go some way to, I should say this is work in progress. So you'll see that we're progressing on this third bullet point, but we're not fully there yet. But we're going to try to explore reasons why these state-owned enterprises are not obtaining the same productivity boost as the private-owned firms. And what it looks like is that these state-owned enterprises are not shifting or making the appropriate capital expenditures in terms of human capital and physical capital, okay? So sort of stepping back for a minute, coming back to the beginning of the talk, it looks like, in general, when you adopt these robots, so long as a firm is also making investments in physical capital, digital capital, human capital, you'll get the productivity boost. But if you don't make these investments, you won't. And it looks like the state-owned enterprises are having a lot of trouble doing that. Now, we argue, this is the fourth bullet point here. So we argue that part of the reason why these state-owned enterprises don't do that is because they don't have the sort of market-based incentives that force them to that forces private firms to make the complementary investments, right? So the state-owned enterprises don't have those same market-based incentives, and therefore they are not making investments in the complementary assets that they should be making. Okay, and I'll provide a little bit of evidence that supports that idea. Let's see, why don't I pause just for a moment? Erik, any pressing questions?
Yeah, there are a few questions. I mean, maybe you could say a little bit more about how you define robots. Right up in the beginning, you said they're easy to count, although, I mean, some of us have Roombas and smaller
Right.
robots. Can you say a little bit more about how you're defining robots?
Yes, and let me do that by actually just moving forward.
Okay.
And I'll do these next two slides that'll get at that. So so here's what we're going to do. We're going to construct a large panel data set that's at the firm level. Let me just say a little bit more about that. So we're working with something called the Annual Survey of Industrial Firms in China, the years 2000 to 2013. For those of you that are academic researchers that have worked with census data, this is like the equivalent of the annual survey of manufacturers that the US Census Bureau puts out. So this is going to provide us with a lot of accounting data, stuff like revenues and employment and wages and things like that. And what we're doing is we're matching that to data that we get from China's General Administration of Customs. Okay, from this data set, there's information on all sorts of stuff that gets imported, and some of that data is data on robots that are imported. There are, off the top of my head, I don't have it here, but off of the top of my head, there are maybe 11 different categories of industrial robots. When I say industrial robots, what I mean is robots that would be used in a factory, right, like a manufacturing establishment, as opposed to a Roomba that would be used in a home, right? So these are all sort of robots used in a manufacturing setting. So
Okay.
Erik, hopefully that gets.
Yeah, and so they don't. What about like surgical robots? Someone asked about that, and doesn't. I assume it doesn't include the household ones.
Yeah, so we don't have any information on household robots. That's a good question about surgical robots. I don't know if that data is collected. We're not using that information because the healthcare industry, right, which is where you'd have the surgical robots, don't show up in this data set. So this is a data set of manufacturers.
Yeah, that makes sense. And Irving Wlodowski-Berger and others have some questions about the state-owned enterprise and others. I think maybe maybe it'll make sense to wait until you sort of present that stuff, and we'll dive in a little bit more about what some of the differences are.
Okay. I'm coming back a slide. Okay, so we're going to construct a large panel data set, and then we're going to use the data to show, to explore, if you will, the link between robots and things like productivity and employment. So I want to say from the outset that, unfortunately, we don't have a neat natural experiment here. At the end of the day, what I'm going to be doing, I guess, is showing you a bunch of correlations. I believe that some of what we're seeing is causal, but I'll be careful how I say that. We know that there's tons of endogeneity. There should be, by the way, right? I mean, these are expensive investments that firms are making. They are not making them randomly, right? There's no randomization. We wish we could do more with this in terms of addressing the endogeneity in the selection. All that we're doing right now is using firm fixed effects to try to help us with that a little bit. There's more that we could be doing. I'm happy to take suggestions via email, let's say, and things like that. So for example, we have been looking for, there aren't any national shocks during this time period in terms of industrial policy or something like that. We have been looking for local industrial policy shocks. We haven't found anything yet.
Well, I don't know if you want to get into that right now, but particularly with the effect on employment, it does seem plausible that if there's a demand shock, that would lead to more robots and more employment at the same time. Yep. And not necessarily the robots causing the employment, right?
Yep. And that story, Erik, is, I think that's the most plausible of the alternative explanations and the one that we worry about the most. Yep. Now, part of what so all that being said, part of what we care about here, so we're going to care about showing or sort of documenting this correlation, for lack of a better word, between robot adoption, and it's going to turn out that we do see employment growth and productivity growth. But part of what we're doing is we're then comparing the differences across private-owned enterprises and state-owned enterprises. So Erik, your alternative explanation, in order to explain some of what we're finding, you would then need to say a little bit more, like you would need to then push the alternative explanation to be something around state-owned enterprises are getting a different demand shock than private-owned enterprises.
Yeah, or as well, I mean, since you brought up, so Irving brought up that state-owned enterprises also have different goals in terms of, protecting employment perhaps, or than private companies do.
Yeah, and so we're going to find that there's actually less employment growth at the state-owned enterprises. And so if anything, it's curious that they're not sort of getting some of the benefits that it seems that private-owned enterprises are, right? I mean, so private-owned enterprises, it turns out in China, we will see employment grow there once they adopt the robots, and we don't see that for the state-owned enterprises. One other thing that we're going to take advantage of is the fact that there's different types of state-owned enterprises, and this might be what one of the questions was getting at. So there are state-owned enterprises that are sort of at the central level, right? The central government level. There's some that are at the provincial level. There's some that are at the city level. And so one of the things that we're going to do is sort of take advantage of differences across those state-owned enterprises. And it's going to turn out that the state-owned enterprises that are at more of a local level start to look a lot more like private firms relative to the state-owned enterprises that are at more of this sort of central high government level. We're going to use that to sort of help. Sorry, let me just come back. Where are we here? Yeah, it's the results on that we think sort of partially help us to make this argument here that the Chinese state-owned enterprises lack the market-based incentives because again, it's the ones that are sort of closest to the market that we then see that difference no longer showing up, right? So it looks like they are responding to the market-based incentives. Okay, Erik, I'll sort of forge forward unless there's other.
Well, there definitely are more questions. If you'd like, we can address a few of them right now. So I can, yeah. So there's a question from Avner Ben Nair about the complementary assets at the Ohio plant and whether or not there are these different components, the physical tech hardware that may be required, like the wheels versus and the optical equipment, and how they all fit together.
Yeah, so I see Avner's question. Yeah, it's a great question. So, so Avner, thank you for the question. I agree with you. I mean, I think that you can think of this as, when you invest in robots, you have to, or you should invest in everything, right? It's not just the robot, but also the physical capital, the soft digital capital, if you will, and the human capital. Two things though. One is we're going to see some evidence that these Chinese state-owned enterprises don't make those investments, right? And so perhaps therefore it's not surprising that they don't have the same employment and productivity boost. The second, and this one is a little bit more subtle, which is that ex ante firms don't necessarily know what those complementary investments are, right? So the complementary investment for firm X might be different than for firm Y, right? So I could go back to the picture, right, and show you, but if you remember, it was a very specific piece of metal that the robotic arm was sort of presenting to this very specific stamper that firm had. So what that firm needs might be different, right, when it comes to robots relative to what some other firm needs, right? And so this is why this sort of the role of market-based incentives to try to find the appropriate complementary assets we think is an important part of our story, right? So managers that need to sort of make the right decisions are incentivized to make the right decisions. Those are going to be managers at private-owned firms. At the state-owned firms, there's just less of an incentive to do that, or at least that's our argument to explain, at least partially explain why the state-owned enterprises are having such trouble making the investments in complementary assets.
And sort of related to that, there's a question about the different kinds of jobs, or parallel to that. Do you have data on the different kinds of jobs that are being added? Is it
Yeah, great question.
Yeah,
great question. So we do have it for for some of the years. Do I say it here? I guess I don't, yeah, so I don't say it on this side, but for the years 2004 and 2008, we do have information on categories of jobs. So what I'll do is I'll first just show you jobs in general, and then for those 2 years, we'll do a little bit of a deeper dive on the jobs. And so maybe I'll sort of hold off on other questions now until I get a little bit further in terms of presenting the results.
There are lots of very interesting questions in there, but let's give you a chance to present the basic results, and then we'll dive in.
Okay, great. Okay, so that's the data. Now, one of the things that we have to do is validate the data that we're using, right? So again, just to remind you, so we're using this China's General Administration of Customs to identify which firms are importing robots, okay? We are focused on 2000 to 2013. If you recall at the start of the talk, I noted that it wasn't until 2013 that China's domestic robots, that China had domestic suppliers of robots, okay? So one of the things that we do to try to validate the data that we're collecting is we compare the import data that we have to the aggregated IFR data. Okay, so our data is the blue series that you see here. The IFR data is the red series here. So it's not surprising to us that the two aren't completely on top of each other. We think that we're getting a better measure of which firms are, or just of the amount of robots that are being imported into China. IFR collects its data from it's a trade group, so it collects data from members of its trade groups, and so it's going to undercount, which is why you see that series is below our series. What's useful to us, though, is it looks like the two are more or less parallel, and where there's increases, you see them in both series, decreases, you see them in both series. So this is some validation that we've got. Here's some summary statistics. Again, let me highlight that this is work in progress, and so the actual sample that I'm going to be working with for some of the regressions that I show you and things like that, it's going to vary a little bit. This is all a little bit of a work in progress. The one thing I want to highlight here is just how few firms in our sample are adopting robots, right? So this is 0.2%, right, of these 2 million firms are adopting robots. Okay. About 4.5% of the firms are state-owned enterprises. 10% of those are at that very high central level. Roughly 1% total firms are central or provincial, and then the rest are more at the local level. So again, I want to highlight this as well, because this is sort of an additional source of variation that we're going to exploit in our in the project. Okay. This is just almost like a sanity check. What we're doing here is we're showing which firms are likely to adopt robots. And the thing to highlight here is that it's the larger ones and the more productive ones that are adopting robots. This lines up with what we see in other papers. Okay, so our regressions are going to have the following form. We're going to be looking at certain outcomes like productivity or employment for firm I in year T. It's panel data, so we'll have firm fixed effects and year fixed effects. We're going to have this robot, this dummy variable for robots that turns on the first time that we see the robot, the first time that we see the firm adopt a robot. We also, I should say, have the dollar value of the robot inputs, and we've everything that I'm going to show you, we've also done it with the dollar value of the robots, and you get similar results. So this is one thing we're going to be focused on. The other thing that we're going to be focused on is the interaction between the adoption of the robot and then whether the firm is a state-owned enterprise or not. Okay. Here's the first set of results. Here we're looking at total factor productivity. So if you will, it's a measure of performance. And what we find is that when the firm adopts robots, in subsequent years, you see a roughly 3% increase in productivity. Okay, so that's on average across all the firms that are adopting robots. And then when we break it out by whether the firm is a state-owned enterprise or not, it turns out that the higher the level of the state-owned enterprise, the less likely you are to see these to see the productivity boost. Okay, that's TFP. This is labor, right? So employment. So firms that adopt robots see an increase in employment. However, you don't see that increase if you're a state-owned enterprise, and particularly if it's a state-owned enterprise at a relatively high level. Okay, so summary of the results so far is that the robots are associated with higher levels of productivity and employment in China on average. However, state-owned enterprises do not experience the same productivity and employment boost as private-owned enterprises. So why is that? So there are perhaps multiple reasons for that. Here are a few. Maybe state-owned enterprises are underinvesting in human capital. Maybe they're underinvesting in physical capital. Maybe they're not investing in robots because they want to see a productivity boost. Maybe they're investing in them for show. Okay, right? Purchase a robot, take a picture next to it, type of a thing. Or maybe they're investing in these robots for sort of learning or reverse engineering type purposes. Okay, so what we're going to do next is sort of systematically go through these three. We haven't quite gotten to the fourth one yet, but I'll show you some evidence to try to get at least these first three reasons why the state-owned enterprises are not experiencing the same productivity and employment boost. Okay, so if you recall earlier, I was mentioning the importance of investing in human capital. What we're going to do is we're going to work with the 2004 and 2008 data where we have information, a little bit more information about the type of workers, right? This was to the question that came up earlier. So we know the number of workers at the firm that have college education or higher, right? A college degree or higher. We know the number of firms that are engineers or other sort of technical workers. We know the number of workers that have a professional certificate. So it could be, an accountant, or it could be anything that sort of ends up being certified. And we also know, male and female workers. Okay, so what do we find? So when firms adopt robots, they have so we know that I already showed you they have an increase in employment. So what's that increase in employment coming from? Well, the firm is hiring more college educated workers. Maybe more have certificates, although that's not statistically significant. More technical workers and more women, okay, on average. Okay. However, except for these state-owned enterprises, again, at the central level, for them, you don't see these same increases, right? So if you sum these, it'll come to 0 or even less. Okay. Okay, so it looks like these, in other words, it looks like these state-owned enterprises are underinvesting in human capital relative to their private-owned enterprise counterparts. Okay, what about physical capital? So we have a few measures of this. I'm just going to show you this one here. We're just going to actually look at capital expenditures in the year that the robot is purchased. And again, for the firms that, and this, we've netted out the cost of the robots. So for the firms that are adopting robots, they also see an increase in other types of capital. And there's some evidence that, however, that this is not the case for the state-owned enterprises, okay? Although this is not statistically significant. Okay. The third one, what about investing in robots for show, not for productivity? So it's a little bit of a hard one to get at, but I'll tell you how we're going to do this. So the argument would go sort of like this. So if robots are bought for show or reverse engineering, you might expect that the dollar value of the robots to be low for the state-owned enterprises, right? So imagine a state-owned enterprise and a private-owned enterprise, each of which has 5 lines, right? My 5 fingers, so 5 production lines. The private-owned firm, if they're adopting robots, maybe they would adopt 5 robots. Let's say 1 for each of the production lines. The similar-looking state-owned enterprise, if they're purchasing for show, right? They just want a robot to sort of show the local party official or something like that. Maybe they would just purchase 1 instead of 5. Okay. And so what we're trying to do is we're trying to get after that idea, right? Is that what the state-owned enterprises are doing? Or does it look like they're purchasing similar to the way private-owned firms are doing? And so what we do is for each year in our sample, we sum up for private firms and for state-owned firms, the total amount of robot investments. And then we divide by we've done this a few ways. Here we're dividing by firm output, right? So firm revenue as a way to try to normalize by size. And now we're sort of plotting these two time series. If it was so in orange is the private firms, the non-state OEs, and the blue is the state-owned enterprises. Now, state-owned enterprises, it bangs around a little bit more because there are fewer of them. And so if they made like a very big purchase in 1 year or not a very big purchase, that's really going to move things around. But in general, it looks like those two time series lie on top of each other. And so this suggests that the state-owned enterprises and non-state-owned enterprises are purchasing robots in roughly equivalent amounts. And so we think that this is some evidence that works against the idea that state-owned enterprises are investing for show. Okay, so what do we have so far? So again, looks like they underinvest in human capital, looks like they underinvest in physical capital. It doesn't look like there's evidence suggesting that they are investing in these robots for show. Now it's possible that maybe they're investing in these robots because they're trying to do reverse engineering or something like that. Again, I think the fact that we can probably rule that out starts to rule this one out a little bit, because if you're going to do reverse engineering, again, you only need it for one line. You don't need it for your 5 lines of production. But there is more that we can do here. And maybe I'll say more about that when we get to the Q&A. Just taking a look at the time quickly.
Yeah, maybe about another 7 minutes or 8 minutes, and then
Yep.
we'll do broader Q&A, or you can use it as you want.
This is great. I'll be done in 5 minutes. Okay, I'm just going to sort of wrap a few things up here. So here I don't have any results to show you, but I can just sort of share these results with you, sort of verbally. Another thing that we've done to sort of explore what's going on with the state-owned enterprises is to take advantage of a data set. It's called the NERI, N-E-R-I, and I forget what it stands for. My co-authors, who I believe are on the webinar, would know, and maybe one of them could type it into Q&A if they feel so inclined. But what NERI does is it provides an index that varies at the local market level in terms of how much the government interferes in that market or not. And so we use that as another dimension, another source of variation in terms of how focused on market incentives private firms and state-owned enterprises would be. And again, we find some evidence that that sort of lines up with our general hypothesis that you need these sort of strong market-based incentives in order to make the correct investments in complementary assets. Okay, so just summarizing the results so far. So we find some evidence that robots are associated with productivity and employment increases in Chinese firms on average. State-owned enterprises don't appear to experience the same productivity and employment boost as private-owned firms do. And it looks like a lot of that is due to not investing in human and physical capital to the same extent as the private-owned enterprises are. We're still sort of exploring some of these ideas. And so, very welcome, open to suggestions. Overall, though, I think, it points to, this is the last bullet point, it points to the importance of the investment in complementary assets in order to benefit from investment in new technologies. So we think that it's not a paper yet, but ultimately it will be a paper. We think it'll contribute to 2 different literatures. One is a literature on automation and firm production that has highlighted the role of complementary assets. And the other is a literature on SOEs. And we think that understanding what particularly Chinese SOEs are doing is important, given the role that the Chinese government has recently sort of started to rely on SOEs for in terms of trying to popularize and push the adoption of new technologies. So Erik, I think I'm a little early, but I can stop there.
Well, that's great. I have a lot of questions. I know a lot of other people who have a lot of questions as well. So
great.
It's great to have some time for us to have a discussion. First off, amazing data. Thank you so much for sharing these results with us and describing what's happening there. Let me start the discussion by asking about this relationship you're finding among robot adoption, employment, productivity, capital investment, all these variables. I want to explore flipping the regression around and making this an adoption regression rather than a productivity or performance regression, that you could put robot adoption on the left-hand side and say, what are the things that predict it? And going with you stressed endogeneity early on, but going with that story, you could imagine that private firms, when they see a demand shock, are likely to adopt robots. Whereas state-owned firms, as you were beginning to explore there, maybe they have other reasons for adopting robots that may or may not relate to demand shocks. They're not, probably, one would guess, not quite as market-driven, and whatever their incentives are, I don't totally understand, but they're probably less driven by demand shocks. That would be consistent with your results. That when you see an opportunity and you're a private company, you invest in capital, labor, robots, etc. You also probably have more productivity because you see this growth in output. Whereas the driver for the state-owned firm, I think you're beginning to explore that a little bit, but maybe there's some other reasons that they do it, or just generally more muted incentives, and so you wouldn't see the same level of correlation. I didn't go through all of your results, but that seems to match with some of them or many of them. What are your thoughts on that? That part of the story.
Yeah, a couple of things. So first, Erik, thank you for the comment. I think that's a useful way to think about it. We have looked at adoption, and we've looked at state-owned enterprises versus private-owned enterprises. But one of the ways to think about your question, as I'm interpreting it, is think about almost like interacting the state-owned enterprise dummy with some of these other factors that might predict adoption, right? So we haven't done that, and we certainly can do that. We've looked at state-owned enterprises as like a dummy variable on the right-hand side, but we haven't interacted it. So we certainly can do that. I also wanted to say, and I think I mentioned this at the start, but I really want to highlight it, and I'm not trying to butter you up by what I'm about to say, but your work, and particularly your recent work with Christina McElhern and Jin from MIT on the role of complementary assets and predictive analytics. I think of that paper and the Dixon, Hong, and Wu paper as sort of the two papers that we are closest to, right? In your case, you're looking at the role of complementary assets when it comes to predictive analytics, and we're trying to do something similar here, but with robots.
Yeah, well, I appreciate that. And I think there's a whole agenda around this. And what we should be doing, and also what you might be able to do, is ultimately have a system of equations, simultaneously estimate both a production function or productivity equation and also an adoption equation. And then the trick that we all are having trouble with is finding exogenous drivers of either adoption or of productivity, and see whether or not we could distinguish some of the causality, but as we all know, there's probably a bunch of it that's endogenous going in both directions. Let me turn to, there's a bunch of questions. I don't know if you can see the Q&A, but let me pick out Zhupeng Wang's question. And he asks if you could explain a bit more about the differences between and among SOEs versus POEs. And his hypothesis is that SOEs are more likely to be industries with less competition. They may have higher monopoly power, like petroleum refining, and they may have more pressure to be stable from a national security perspective. So those would be some characteristics. It goes to your point that you're not like randomly assigning some to be SOEs and some to be POEs, but that they're in different, they're different kinds of industries and different kinds of constraints.
Yeah. So thank you, Erik, and also Zhupeng for the question. So you've highlighted that we have two selection issues. One is who's adopting robots and not, and then the other is, well, why are some firms state-owned enterprises and others not?
Right.
So to the question about industries, so we one thing we could do that we haven't done is sort of break this out at a high level and sort of see whether the results vary in an interesting way across different industries. Thinking about industries where there's, let's say, more state-owned enterprises versus less. It's certainly the case that there are some industries that are strategically very important for China, and so there are more state-owned enterprises in those industries relative to others. So I think it's a great question. We haven't yet really done much to explore that angle. I think Shuping also has another question on, I'm reading it. It says, do you have any managerial measure of the state-owned enterprises
right.
or other investment in intangible assets? So no, we don't, but what we do know, so we know whether the firm is a state-owned enterprise or not. And then we also know what level for the state-owned enterprise, right? By level, meaning, whether it's run by the central party or provincial or even, local, sort of city-run SOE. And so again, we're sort of trying to take advantage of that source of heterogeneity across SOEs that we have. But we don't have anything else about sort of like some sort of managerial measure. We don't have that.
And a little bit related to that, I think you're touching on, but David Epstein specifically asked about the employment growth of the different, if there's different kinds of employment growth in white collar or product line work, production workers. Could you say more about the different kinds of workers you're able to observe?
Yeah, so for most years, we just observe employment, and we don't know who those people are.
Just
as I highlighted for 2 of the years, for 2004 and 2008, we know a little bit more about the makeup of the workers, right? We know whether they're college educated, whether they're technical workers, whether they're a man or a woman. And so again, for the results we have there is that the private owned firms, we see a shift in the makeup of the workforce, right? Becoming more educated, more technical, more women, interestingly. So for those private firms, we do see that shift once they've adopted the robot, but we don't see that for the state-owned enterprises.
Gotcha. Karen Eggleston asks about the baseline productivity differences. Actually, it's a good point. So you're looking at some of the changes, but were the private enterprises initially more productive?
Yeah, Karen, hi. Great question. And one that I should know off the top of my head, because we did look at that. I don't remember specifically, but if I had to guess what I would be remembering, it would be that the private firms are more productive than the state-owned enterprises. But I don't remember. I'm sorry, I don't have more than that on it. It's a great question.
Great. Shmuel Yerushalmi asks whether or not how the COVID pandemic may be affecting all of this. I know your data is from before that, but I think we can broaden the discussion a little bit about people having to social distance or maybe use machines more than humans.
Yeah, boy, that's a great question. So again, just to be clear, the data that we're working with is 2000 to 2013. So we can't say anything about COVID. That doesn't prevent me from speculating.
Yeah, feel free. We're in the last 10 minutes here. So.
I don't think it would change the story, right? We might get more adoption of robots in some industries relative to others, perhaps because there's less human capital or something like that, fewer workers that are available to work. But I don't think it would change the basic story that the firms that also make the investments in complementary assets are going to do better than the ones that don't, and that the state-owned enterprises probably don't do that as well as the private-owned firms. So the basic story that we're trying to tell, which is those 2 pieces I just said, I don't think COVID changes that. Yeah. Erik, what's your thought on that? Because I know you've
So Matt Bean and I are doing a little bit looking at companies installing it, and you made the point earlier that it's tough to do plug and play with these systems, and it's because of that. It's not happening as fast as you might expect. It's not like COVID happened and suddenly there's a big switch. It's really, most of these things are a multi-year investment and installation process. Tugba Donachi asked a question. He's been doing consulting in Turkey, and he knows that Turkey and China are different, but noticed that some of the smaller private enterprises behaved a lot like state-owned enterprises. And do you have any data on the different sizes of the enterprises and how, like, whether there's a difference for the bigger ones versus the medium ones or the smaller ones?
Thanks for the question. That's a good question. We have not looked at that. I think you're probably right, that smaller firms probably struggle, just like the SOEs struggle. I mean, I think they probably struggle for slightly different reasons. Maybe a different way of saying it is not small versus large firms, but you could also imagine splitting firms by sort of, let's call them the higher productivity firms. And so by the way, it tends to be the higher productivity firms and the larger firms that are adopting the robots to begin with. And so it would be odd if we saw many small firms adopting robots in our sample during this time period. Same thing for like the lower productivity firms. We're just not going to see many of them. But so my guess would be that the smaller firms or the less productive ones that are adopting robots, probably look a little bit like SOEs, mm-hmm. in the sense that they're not getting the same productivity and employment boost. Mm-hmm. I've seen a couple of questions that look similar. So for example, Abhishek. So hi, Abhishek.
Yes, Abhishek.
So do Chinese companies not use locally manufactured robots? Will you miss those? There was basically no local Chinese robotics industry until 2013. And so again, that's part of the reason why we are 2000 to 2013. So Abhishek, I think that gets to your question, but happy to chat more about that offline. Oh yeah, and so, but let's take that point about will we miss them, right? So maybe there were some, and so maybe we are missing some. Now, keep in mind what that means, right? It's going to make it harder for us to find an effect, right? So we see firms that are adopting robots. And so to the extent that we're missing firms adopting robots, then they're going to show up as not having adopted robots. So that's going to make it harder for us to find an effect. Okay, and so if anything, it sort of works against us. I've seen a bunch of questions that are on why China. My response to that is, there's a lot of the literature that is, I'm thinking here about sort of the economics literature in particular, has focused on OECD countries, right? So there's data from, at the start I mentioned, papers that look at Canadian firms, and there's a paper looking at French firms, paper looking at Spanish firms, right? So we know a lot about how robots are affecting employment and productivity in firms in OECD countries. To the best of my knowledge, this is the first paper that's using firm level data for Chinese firms. And it's sort of an interesting question. Do we see the same effects that we see in OECD countries or not? It turns out, yes, we do. But now we know that, right? So that's part of the reason why we're looking at that. Erik, I'm happy to sort of pick out other questions.
Yeah. Well, there's one from Christina McElhern. Maybe you want to touch on, she gives you an opportunity to talk about some of the other kinds of data and questions you might want to gather and look into.
Hi, Christina. Thanks for joining in. The question just disappeared, and so I'll try to remember what it was.
But what other kinds of data to get into some of the nuance of what's driving this, beyond beyond the variables you already have?
Right.
And
so
you talked a little bit about the managerial,
Yeah, exactly. So Christina, as I mentioned like 10 minutes ago, your paper with Erik on the predictive analytics, one of the things I love about that paper is you have information not just about human capital and sort of capital expenditures, but also managerial capital. Right? I forget how you guys measure it, but I know you have some measure of managerial capital, and it looks like that's an important complementary asset as well, right? And the firms that adopt predictive analytics that have good managerial capital do better than the ones that don't. And so we don't have data on that, but if I had if I was allowed to sort of collect whatever I wanted, it would be something that would try to get at that. Thanks, Christina.
Terrific. I'll give you a chance if you want to look at, there's a bunch of questions here. I can pick some, but also want to give you a chance to make sure if there's something you wanted to address.
There are so many questions. It's wonderful.
It's hard to keep up with them. Let me give you one. Okay, go ahead.
Oh, no. Yeah, sorry, go ahead.
Well, This is now, we have just a few minutes left, so to give you a chance to talk a little more broadly, you're looking specifically at robots, and maybe you could say about how you see this as being different or similar to advanced technologies, AI or IT more generally, or what are some of the special characteristics of that you think are important about robotics in China?
Yeah, so right, this sort of circles back to the conversation, or sort of where the conversation started at the beginning, right? So I'm focused on robots because I'm able to count them, right, over at the firm level across many years, right, 2000 to 2013, and so that's useful from a measurement point of view, if you will, from the point of view of doing some statistics and econometrics. So I think the big open question is, well, what about like other types of technologies like AI, right? And so Erik, we were just talking about your paper with Christina, and I know you guys are looking at predictive analytics. A question I get a lot from students and from executives is, well, what do I need to do when I invest in AI? Like, how do I get this right? And the answer that I give all the time, relying on your paper and also relying on the results from this project here, is, well, make sure that you're thinking not just about investing in AI, quote unquote. Defining what AI is, I guess, is sort of a separate, right? But make sure you're not just investing in AI, but you've also thought carefully about what all the other types of complementary investments are that you're going to need to make, right? And so if it's from a budgeting point of view, and the firm is thinking about budgeting, let's say $100K to sort of purchase some AI software or something like that. What I like to say is, well, okay, great. So that's for the AI, that'll get you your engine, if you will. But what about all the other things that you need to get that engine to work? Imagine it's like 3x from that 100K. So you're going to need 300 or 400K, right? Because it's not just the software per se, but it's also other physical capital, human capital in particular when it comes to AI, right? You need individuals at your firm that are trained to work with it and things like that. The other thing that
so Rob, can we do like a lightning round? You've only got 2 minutes left here, and there's a bunch of really interesting questions.
Okay, cool. Let's take the. Cool.
Okay, so let's see. Katya Klinova asked about the whether there corruption or the could that be a plausible explanation of some of the results, particularly in the SOEs? Is there any way you can distinguish that? Sebastian Stefan asks about robot vintage and whether you have the data on whether some companies are leapfrogging earlier ones. And Amaya Mittal asks about where the robots were being imported from, if you can remember all three of those.
Yep. So where are they coming from? They're coming from Japan and Germany mostly. Technological leapfrogging. At one point, we looked at we've got 2000 to 2013. At one point, we sort of broke it into 3 different time periods just to see if the results were similar or different across those time periods. It's pretty similar across all time periods, but maybe there's more on the technological leapfrogging that we could do. So Sebastian, happy to talk offline with you on that. And then what was the first question? I was sort of going in reverse.
Katya Klinova is asking about corruption. So you talked about some of this, why it is that the enterprises behave differently and whether that could be a role. And I guess you also touched about buying them for show or other reasons. Reverse engineering.
So we haven't looked. I mean, corruption's an interesting idea. Honestly, it's not one that we've thought about or looked into. So I think that's maybe a nice one to end on because it's a great suggestion for more that we can do on our end in terms of the research. And so I wrote it down. I've written lots of stuff down, but I did write corruption down, and that's one that I will take back to my co-authors, and we'll take a look.
There are so many other good questions. A lot came in towards the end. Other good questions. I think we'll try and preserve these for you, so you can follow up with a lot of good ideas from Zubin and others. So I'm sorry we don't have time to get to all of them, but we'll preserve those. And also, one of the questions early on was, will these slides be available? Is that something that we can share with people, or is that still?
Yeah, definitely. I'll send them to you after.
All right, we will post them.
Great. Thank you very much.
Thank you so much, Rob. This was absolutely phenomenal. Great stuff. We appreciate you taking the time to share with us. And I want to let people know that our next seminar, we're not going to be doing it on President's Day, but the next seminar will be on February 28th. And we have Guy Eridor speaking about drivers of digital attention evidence from a social media experiment. He blocked social media for a number of users and had some interesting patterns of what they did with that time that they weren't spending on social media. So that's on February 28th here at 12 noon Pacific time. So look forward to seeing you all then. Thanks again, Rob. Really appreciate you joining us.
Thanks for having me, Eric. Thanks, everybody.
Okay, bye.